All right, thanks for attending today's talk on CBOM. Nicholas, is there we have limited availability for Basel this session, so is there anything that we want to potentially discuss while we have him here?
Yes, so on my to-do list, there was still this outstanding one with the certificate extension. I know that Basil had a look at that because he gave me actually the input to put it in. I just pushed it to the branch. So maybe if we can, look at it later, getting the opinion of the others, or even, do it offline and talk about that the next call. But I think the other bigger and also on my list, the last outstanding to do for this kind of reiteration of CBOM would be the standardized naming.
Ah, yeah.
Um,
And that's
and
of curves and algorithms, right?
exactly,
Okay.
yes. So I think we could start with that discussion, and I think there's also Basis input quite valuable.
All right. So Basel, just for my own absorption, so Basel has already looked at the modifications that you've made to that PR for the extended cryptographic extensions, right? The cryptographic for the certificate extensions.
Uh,
And we're going to do that offline or
yeah, we looked at it together before
okay.
today before the meeting. Basically
Okay.
about some of the like some certificate extensions for both X519 and CVC, and
Okay.
um,
Okay.
Nicholas knows more about the object structure anyway.
Got it. All right. No, that makes sense. Okay. We can review that later then. So then the first thing in terms of your hot list, you want to work on the algorithm names or was there something else? Algorithm EC? All right.
That would be the one for me. Yeah.
All right. All right. Um, we had contacted the PhD student at, and I can't remember the name of the university off the top of my head. We had contacted the PhD student who was leading that effort to catalog all of the existing curves, right? And I believe that that could, with a little bit more research, provide a fantastic starting point for us. Because they've done most of the heavy lifting already. For the list of algorithms, other than like getting something from like Bouncy Castle or OpenSSL or something like that, do we have an exhaustive list of algorithms? I know like the SPDX folks, they've tried to capture the output from a tool, which I mean, it's fine, I guess. But do we have like a more thorough reference for that anywhere? Does anyone know?
I mean, the quick answer is no from my side. But I also, I think I mentioned also last time, but for me personally, I think enumeration of algorithm names maybe not the right approach in terms of the specific namings and kind of Wild West patterns that you see in naming conventions, also related to the parameters that are used and that we find in the kind of CBOM structure when we look into algorithm properties. That if we keep the current naming convention, which is related to basically how the algorithms are commonly referenced, looking at AES, looking at RSA, we put key size and mode in the name. And to be able to do that, there's more logic than just an enumeration, because how you combine those things and in which order and what characters you use, this will be, there's no common pattern to
Right.
do that.
That's kind of what I've seen between like OpenSSL and like Java, right? Because they all have like these extensive lists of names and they're kind of represented slightly different.
So
even between like case sensitivity, right? Ones are uppercase, one's lowercase, right?
so I think, I mean, that's just my idea, or not my idea, but like kind of how I would see it regarding the algorithm names. For me personally, it would be good if the algorithm names are very close to what we will see in regulations and documents, because I think eventually the output of a CBOM is compliance related, and we should, kind of, I wouldn't require a translation document from CBOM to the compliance document. Having their specific pattern of algorithms that we just use for CBOM, and then people have to translate that to understand what the algorithm actually is in their compliance document. So being there quite close to the real world naming would be, for me, a good reason to do it that way.
So you are suggesting then, if I can kind of reiterate, I guess, so like if we have AES, right, we don't want to go down the path of like putting the size, the mode, all this other stuff in the name. We just want to standard on like AES, right? That's the name of the algorithm.
We do
Or
currently put those things in there, and in a way that is commonly seen and used. So IS minus 128 minus CBC,
right,
and then minus the padding if it is there.
right.
So
So
we
do we
do
want
that.
those in the names?
Debatable from my point of view. That is how you would find it most of the times, as in documents, and not just AES, also like the full name. And if we
Right.
want to have it close for compliance reasons or no need to translate reasons, then we could do it that way. Also nice to display it that way if you have a UI and you just read it. But yeah.
So in some cases, then the name would duplicate some of the data that exist in the structure already. Okay.
Yes. I mean, I think we had also the discussion at the beginning where we did not capture all the possible data in the kind of data structure. So the name was kind of more specific in some cases than we actually have data structure objects for, or not more specific, but captures other. I think the first thing was we had a key size or something like that. But we changed it into parameter set identifier, because in some cases the algorithm is not defined by the key size, more like by a combination of some parameters. I think special case or a case example for that would be the Kyber, or was the Kyber algorithm, which has 700 something, that which is not the key size.
Has your employer have your research team standardize on a way to kind of represent the order in which the different things are represented in the name? Is there consistency for that?
No, we basically took the naming convention from the origin papers where the algorithm were defined. And we have kind of in our library to generate CBOM, or basically the algorithm name, we have a function that if every parameter is there, construct the name according to the actual document, how it's described in there. So it's not a common pattern, but we have a common library to do that.
Okay. You have a common library. Does that mean you have an enumeration of these somewhere?
Yes.
Okay.
We do.
Is that able to be shared at all or no?
Yes. Yes, it's
Okay.
part of the open source tool we open sourced.
Okay. Right. Is that the SonarCube one or something else?
Yes, it's a SonarCube one.
Okay. All right. All right.
So when I mean, just in general, when we talk about standardizing the algorithm names, right? Do we envision to standardize, let's say, an enumeration, like with the curves. Or, I mean, the other approach would be to kind of have a standardized way to, let's say, a naming convention, right?
Yeah.
A bit more strictly. I mean, just thinking. I mean, I agree. I think it makes sense to encode kind of more information than the algorithm family, right? Which
Okay.
is kind of AES, right?
Right.
And then there are, you know, the parameter or parameters basically 128, 192, 256, and then you have the modes, right? You have some don't know, maybe 10 modes, right? Maybe you can come up with that. And then some paddings as well that we could as well encode, and then just I mean, we multiply each of those, right? Like 2 times 10 times 5 times 5, and then you can already come up with quite a big list only for AES, right? That we would have to put in the enumeration. Yeah, I mean, that's something could be done, right? Just then we look at different algorithms. Then you also have this kind of algorithm family. You have the parameter, you have some encodings, maybe some paddings, and which at the end means that the list will be quite big, right? Yeah, I mean, that's just something to consider, maybe a bit more than a curve, right? An elliptic curve. There it's okay, you have one elliptic curve, that's it. You don't have, you don't have variations of it that you need to track. No. I mean, a way around having an exploding list would be just to kind of to standardize the algorithm family name. Or only the algorithm family name and the parameter, maybe. So you would have like AES 128, 192, but not more than that.
Right.
So
but the modes and the padding and everything else, use the existing object for that.
Yeah, I mean, there are some. It's not too clear to me yet, right? Which level of exhaustiveness we should go into there, right? Yeah.
Yeah.
I mean, for me, the question here would be, so as I said, we did a little bit of the enumeration in Java, basically, having as we wrote this library in Java where we have all the list of algorithms, how the names are collected, and also what we put in there is basically some parameters you actually have to kind of get from the research papers. So there is the name encodes some of them, like mode and padding, but sometimes there are parameters even for IES. There's a block size there, but there's also other parameters that is not encoded in the name that you actually want to capture if you generate CBOM. So this kind of mapper library, which has objects for algorithm, encodes those parameters also, which from my point of view is something we should share because, you know, no one should do this work twice. And if that could be part of the Cyclone library that will be used to generate CBOMs, would be, from my personal point of view, the ideal place. But I don't know if you have any kind of a different view on that related to maintaining and stuff, and also supporting it for other languages.
I do think we have an opportunity to I do think we have an opportunity with CBOM to kind of bring a lot of folks together in terms of how things are named. I don't personally have an opinion because for me, kind of as Basil was saying, right? For me, there's not a clear path. There's not a clear winning way to do this. Every single option that's in front of us to do this is a compromise. So there isn't a very clear path to do this. Because every implementation, because whether it's a full enumeration, whether it's guidance on namings, whether it's, talking about the granularity of how big the name is going to be, depending on how much things we stuff in there, everything is a compromise. I think what we should likely do is figure out what is the most common, what is the way that we can represent these names that is the most common across all algorithms, and determine if there is existing precedence for the order in which things come, and just use that. And then hopefully as more algorithms come forward, they can start using the existing way that we name things. I do think that from a specification perspective, it is a lot easier for parsing if you have an enumeration. I know exactly what to do with an enum. If I have to parse the name to figure out what it is, I think we've failed. Therefore, I do think that anything that you can potentially stuff in that name, we should have parameters for, and I think for the most part we do. But I don't want to necessarily overload the name. I would like to come to a consensus at some point where we, as Basil was mentioning, we choose the right level of granularity for the name, because again, enumerations are really easy to parse. I don't have to think about it, and I could really quickly validate that. I just don't know what that level of granularity is.
Maybe, yeah, okay, I understand the problem. Maybe I have a different view on that, and I try maybe to kind of share that a little bit more by just quickly sharing some small thing from this library. I hope you can see the code. It's not too complicated. I try to really, go not too much into detail, but basically this is the IS algorithm Java class. And what we do here, we have a base name, which you can change, but this is like base name, and depending on what parameters we capture while scanning, like a key length, a mode, or a padding, there's a specific string builder schema here to add those. And for IS, familiar. But it went through some examples, and this is something I think it's supported by Bouncy Castle, the swarm or SWAM algorithm. And actually the naming convention here uses the XXX is basically the rate of the algorithm, specific parameter, and the Y is basically the capacity, which is related to the key length. And we don't capture a rate because this is something specific for this algorithm or the specific parameter. That's how I understood it. But it's part of the naming, and the convention is not even close to what we have with IES. Very unique. And if we now try to adapt it to be closer to IES, I don't know if someone would then recognize the algorithm, because there are some parameters in there that doesn't normally appear there. And there I'm struggling with to have a common naming and not this specific one, how you basically normally see this algorithm in documents referenced, or and there's not only this example, there are more where it's unique and specific parameters are in there for the naming.
Got it. In this particular example, it's not just the parameters that are very, very different from like AES, for example, but you're also introducing case sensitivity.
Yes.
Which Yeah.
I mean, maybe what we just don't want to, but maybe a thought here, we could maybe add under the algorithm properties actually a new property that we can enumerate, which is the algorithm family as a first step. So having IS as one family, having swarm or swam here as one family, that already kind of helps, I guess, or solves a lot of cases, even if the name is maybe different then. But yeah, because then you can construct the name from the parameters, the necessary parameters that we, or the parameters we can already capture in most cases.
So the rate could be, can the rate today be represented in CBOM?
No, I think that's also something specific. I mean, yes, we can add a property, key value pair, but I think that is even something specific just for this algorithm. That's not the value that you see in others. But please, Basil, correct me if I'm wrong.
Well, even things like I'm wondering how you do like bcrypt, for example, because that has like the number of rounds, for example. No, there is no bcrypt.
I don't think so. No, so we just have algorithms here that we found in this 3 libraries we support, and wasn't in there. So yeah. But yeah. I mean,
naming is the hardest problem we have, right? No matter if we're naming software or children or algorithms. Yeah.
But I think just looking at the use cases, we could already be fine by just standardizing the algorithm family and having that as a separate property. I mean, name is, we can't create an enum for that because it's, it's a common property, which is a string.
Right.
But we could introduce an algorithm family as a sub property and have their members.
What would help you guys from a generation and consumption perspective? Because you guys have built a lot of tools that do this already.
I think from the consumption, it's just about validating compliance and regulatory compliance. And there, I think it's good when we have the algorithm family plus possibility to find the necessary strengths like from the parameters or mode or stuff, which are also explicitly mentioned. Yeah, otherwise I think that would help in a lot of cases, but if I would look at the swarm or swarm case there, even that wouldn't help because we don't have all the parameters defined somewhere, so we can't reconstruct. Basically, if we have the name as a one side of comparison and the CBOM over there on the other side, we can't really match them.
Is there an opportunity for us for the name itself? Okay, I understand, like the easy thing is to standardize the algorithm family, and I agree that's probably worth doing. Is there an opportunity for us to take what you have here in terms of algorithms and how the names are constructed and put that in the CycloneDX documentation as guidance so that others can also follow the same thing, although we will not validate that that's actually being done, because I don't know how we would even validate that. But we could put on a per algorithm basis, we could put that guidance in there.
Yes, I think that would be useful. Yes. I mean, we don't have an exhaustive list here, but it's a good starting point, maybe.
Yeah.
Yeah.
Okay. we talked about the other algorithm as well, the swim, I think it was, and they had a rate, and of course, bcrypt has rounds, and other algorithms have their own things. Other than using properties for this, is there another? Is there anything else that we might want to add? Like rounds, for example. It's almost like iterations. So we could right. So if you are performing like 10,000 plus iterations on something, or in bcrypt, maybe you're performing like 12 rounds, supporting iterations or some other noun that is similar might be good. We also have rate. I don't know if that's just that one algorithm or if it applies to something else as well. Is there, because you've developed this library, is there a gap analysis that you have performed, that the team has performed, that has identified some gaps in the CycloneDX specification that we can't represent today that you think is important?
So from my understanding, what we saw, it's not a big gap. And a lot of times we could map some of the actual like specific names, like capacity in that case, to the key size. We have added, we had added some, well, yeah, we added some small properties that we can also add into CBOM. I think I have to look, but there are just one or two we additionally capture for some algorithms. But it's not a big gap. So
Okay. All right. Is that going to be part of this PR then, or is this still needs to be kind of researched a little bit?
it's not part of the PR, but we can add it. So I think for the next call, I can add the gap that we already discovered, but I don't know if that is exhaustive. Could be that if you would add more algorithm, that there's other properties that we need.
Yeah. I mean, it gets very algorithm specific, right? Like if you have specific parameter types for an algorithm, like, I mean, yeah, rounds, right? Probably
Right.
applies to bcrypt. It applies to AES as well, because different variants have different number of rounds. Yeah, and then, I mean, the new quantum safe standards, they have like MLDSA, they're not identified by key size, right? But one is called 4,4, the other one is 6,5, which is kind of a dimension of some matrix, basically.
Yeah.
This is internally, but that's, yeah, maybe very specific to some of these lattice algorithms. Yeah, not sure. Maybe it would make sense to distill some of common parameters. Or otherwise, I mean, I think what we have so far is we have this like parameter set identifier already in there. So which was like, sometimes an algorithm is identified by the number of rounds, sometimes by this matrix size, sometimes by the key size, and then that would all fit there. Yeah.
Okay, that makes sense.
Yeah. So unfortunately, I have to drop now. So, but see you next
Bye,
week.
Basil. Thanks.
And I will catch up with Nicholas.
Right.
Bye.
The in terms of algorithm family, and I don't have, I mean, I don't have a hard opinion either way, because we kind of did this with the hashing algorithms, where like obviously the SHAs, for example, are all uppercase. I think obviously the MD5 is uppercase, but I believe Blake, for example, is not. I think because Blake 2B, for example, the lowercase b actually means something. So in the algorithm families, I assume this is going to be case sensitive, right? like AES would be all uppercase, and the other one that you showed me would be capital.
Yeah.
It would be sentence case.
I would think that this would be the best approach to not lose any information.
Yeah. Okay. All right. Would it be possible to get that as part of the PR as well, or no?
I think so. I think
Okay.
going through the list we have, plus maybe because I think that's the same thing that the SPDX guys were doing with the list, collecting those information too. Because
Yeah.
I think that's also a Gross and Families plan. Correct.
Yeah. The question that I have is, do we want to have this as a separate standard outside of CycloneDX? So that any tool, even ones that don't support CycloneDX, could adopt?
That's a good question. I think we can't go wrong doing that. Also maybe helps to extend it even without having another iteration, or did you still, like I was thinking you mean then like an external schema,
Right.
external reference. Yeah. Okay.
Yeah, it would be. So my thought is that we could theoretically, if we could standardize the algorithm names and the format in which they're represented, you know, the
Mhm.
how you construct the names, for example,
Mhm.
then any tool, regardless of whether they support CycloneDX or not, could theoretically utilize that standard. So you'd have more tools, at least the newer ones, because you can't change the existing ones because there's legacy there. But all the
Mhm.
new tools that supporting cryptography would then be able to gravitate toward a common way to represent the same thing in the same way.
Mhm.
Because you don't have that today.
Yeah, I think
Um,
that's a good idea.
okay. And then of course, CycloneDX we could make an implementation of that, and it would be a separate schema that CycloneDX would then use.
Mhm.
Okay. All right. Let me run this past Samina over at ECMA and see what her thoughts is on doing this. But I think that would be a good approach. That way, you'd have the international standards body actually behind this. Okay.
Sounds good to me. Yeah.
All right. Do we? Yeah. And then for the curve names, I think the curve names are easy, right? We don't need anything
Yes.
for that, right? It is what it is.
Exactly. Yeah.
Yeah. Okay. All right. Um, I do recall, however, that the list of curves from that university included, if memory serves correctly, included curves that had no implementation, that only existed in research papers, and it included, which is fine. I don't care about that, but it also included duplicates, right? The same curve having multiple
Mhm.
names. I don't know enough about the curves to know which ones those are, and there's like close to 500 of them. So do we want to figure out which ones are the duplicates, and if so, how would we go about doing that?
It's a good question. I've also not a lot of understanding to figure out which are the duplicates. I think in general we should list all, I guess, because people may know the curve from that angle, from under that name. But it would be beneficial to have a hint there that those are actually the same curves, and that they just have different names. I don't know if Basil has had some insights.
Yeah.
Otherwise, we could reach out to the actual creator again. Ask him if he has.
Yeah. Okay. I'll try to dig up those emails too, and get back in touch with them. Who knows? He might have moved on from that university too. I honestly don't know.
Yeah.
Okay. With regard to like something being known as another name, does that same issue occur with algorithm families? Is an algorithm family known in one part of the world by something and in another part of the world known by something else? Do we know that?
I have no idea actually. But from the recent quantum safe algorithm journey, there's already this kind of confusion, not because of different parts of the world, but just then the name changed when it was standardized and different.
Right. So it just because of the rapid pace of the research itself.
Yeah, and I think in this case there was a research name for this algorithm. It has different rounds. There was a naming convention, and when it was standardized, even if it's basically, I mean, there was first, I think, the same algorithm, then it had another name, so it already has not two names. But
right.
Yeah.
Right. Okay. All right, so it sounds like we almost need support for some kind of aliasing as well. Okay, that's fine. We can do that.
Yes. Wonder if, yeah, I mean, it would be useful. But I'm not sure if we want to do that in the first kind of iteration, having this, because I know it would be useful, but even though if not, we have kind of a list of algorithms that you can just draw, it would be still fine. Other people have to deal them with that, but it would be beneficial, just then more work on our side, I guess, to do that then.
Yeah. I mean, it'd be a little bit more upfront work. I think it would be really useful. I think the challenge is trying to keep that alias list up to date. So, I don't know about you, but I just have an abundance of time to be able to do that.
Same.
Okay. So I think it sounds like we have a path forward for the algorithms, the algorithm family, the names. It sounds like we have a decent path forward for the curve names, and then I will take on contacting that person, get engaged again with that.
Thanks.
And then it sounds like we have a few parameters in terms of gaps that we might add to that object.
Yes.
Okay. Now, do we support, I can't remember, do we support algorithm family today?
No.
Okay. It's just a name, right?
Yes.
Okay. Do you know, I haven't looked at it I haven't looked at it since, I don't know, a couple of months ago when they published it. Does this approach align to what the SPDX folks had initially captured from the output of that one tool? Because I know they were using that one tool as kind of like an input for like a authoritative list of license or algorithms.
Yes, I think so. I will just try to load it in the moment. And actually,
Okay.
we will have a call with them, so with these CycloneDX guys who actually did that next Monday regarding CBOM because they are apparently interested. And they kind of provided this list, so I assume we can talk with them also about that and how they envision to maybe provide this list also for kind of, a general,
Right.
let's put it that way, not only for the SPDX.
Right. I haven't looked at it in a while, so I know it had like a bunch of other data in like, so they had like individual files, if I recall, for each one of the algorithms, and they had
Yes.
a bunch of like other data in there. But what I don't recall seeing is like the how you construct the name,
Mhm.
which is like literally the most important part that we
Yeah.
need to do.
It looks like they do the poor man kind of way to put all those things together, which we did in a Java object. So kind of they try to capture that in YAML with all the parameters, default ones, if you have a specific name. So that's how it looks like without basically the feature of using Turing complete language to, do some
Mm.
stuff automatically. But
So,
I
so
think
they have
they,
part of that.
yeah, so we do have, yes, in the library we have the default parameters and they try to capture them too, I guess. So that when
Oh,
you
okay.
reference to, I don't know why my Git is really, I can't actually load it. I just had one YAML file open and now it's just loading forever.
Yeah.
So I can't validate, but yeah, they capture the algorithm ID, which is basically the family. Then they have an algorithm name, which is empty in this case, or in a lot of cases. And they capture the security range, which is sometimes corresponding to key size or block size.
Okay. All right. Um, I can't remember what tool they captured that from either.
I
But
think they use the CycloneDX stuff.
okay. Well, we should probably refer to other tools as well, like, Bouncy Castle and OpenSSL and
Mhm.
all the other types of libraries that exist. I don't know where they got their list from, but if we don't have transparency into how they did that list, I don't know if we could use
Yeah.
that as necessarily input. We literally need the provenance of where this information came from and how it was derived.
Yeah, I don't
Um,
know if just my GitHub is broken connection to it, but I have his link I found from Scanner as a crypto algorithm open data set. That's
mm,
basically where they got that from. I can't open it right now, but
yeah, my GitHub was slow, but it eventually came up.
okay.
I don't know, maybe they're having troubles right now. Who knows?
Yeah. But I think they currently doing something around that. And as I said, we will talk with ScanOS on Monday, IBM ScanOS, and just figuring out what they want to do with CBOM because they were interested. And I will hopefully get a better understanding what they try to do, why they create those data sets, and what their problem is. If it's also kind of algorithm naming and,
I am able
Yeah.
to open it. Do you want me to share? Do you want me to show something from this GitHub?
you have it up.
Yeah,
Yeah,
I've opened it.
it looks like they have. I went to status.github.com. It looks like they have some issues happening.
Yeah.
Like for example, go ahead.
Just regarding the sharing, I actually don't know what is in there. So if you see there's some kind of thing that looks like an algorithm enumeration, that would be nice to see. What they
The challenge with this, challenge with just, let's see, hold on a second.
I see. Now it finally loaded also on my side. But it seems like they have in their YAML files not only the algorithm ID and name, but also like kind of keywords, how they could find that in kind of application code. So this looks like a bouncy castle import. This looks like something from C or C++, some Python. I think they do some scanning on source code and try to find the algorithm there. They encode all that in here. It's interesting. Yeah.
Yeah, but they don't have, again, they don't have the, they don't have how you would actually construct the name. They have a bunch of keywords.
Yes.
Yeah.
Yes.
The keywords part is interesting.
Yeah. They don't have a way to construct a name, which,
Yeah. I just think they will go with this name that they defined there. So the not really the full name.
right. Okay. Does your employer, Nicholas, have any kind of documentation on how, like, if we use this list of names for essentially the family name, does your employer have a list of like ways to construct names from that algorithm name, or is this all stuff that needs to be kind of researched?
I'm only aware of what we did, or
Mhm.
like I'm aware that basically that's I would say the only thing that happens in this space and in our company. And the only thing I know is that this logic is just encoded in the library we developed, so there's no other way to construct it.
Right.
Or at least I'm not aware.
Okay.
I mean, we could publish that then in this guide as a written form as a guide.
Yeah. Okay. All right.
Because we were researching and we only found such things in the actual research papers of the algorithms.
Right.
And we tried to use ChatGPT, which wasn't good for
that.
This does not surprise me. Oh my God. Interesting.
Maybe we should try DeepSeek now.
Yeah, I was going to suggest that.
Yeah, some of these. Yeah, I think some of these algorithm names are questionable as well. Even for Blake, right? The algorithm ID they have is Blake X.
Make X.
Yeah, that's just odd to me. I mean, the algorithm name is Blake, period. And there's not
Yeah.
a lot of commonalities between like Blake 2 and Blake 3. I mean, they're very, very different algorithms. They just don't happen to have the same name.
Yeah.
But Blake X doesn't make sense to me. Let's see what they did for SHA then, if that's the case. Where is SHA? SHA X. Yeah. Okay.
Oh,
Yeah, I don't like SHA X. Sorry.
no.
Yeah.
Okay. But they have these keywords. Yeah.
Yeah, but they include more than alias here in these keywords. For example, in SHA, they add like, I don't know what's this, but it's like a call to a function, create hash
Yeah.
SHA-256, for example.
Right. These are just hints for static analysis tools, I think. That's what
Yes.
these
yes.
are.
Mm.
So if you're
Yeah.
looking at code and if you come across that string, then you know it's that.
Mhm.
Yeah.
Yeah. A nice
okay.
grab.
Right, exactly. Exactly. Okay. All right. So you guys are gonna you're gonna be talking to them next week, Nicholas.
Yes, we talked to
All
them
right.
on Monday.
All right.
They
Yeah.
they had
I mean,
interest in CBOM, so yeah.
okay. Very good. Very good. Yeah. See if they want to be part of the standardization effort, or
Yep.
not. Because we're going to be moving forward with this. Likely, I mean, I'm going to try to do this outside of CycloneDX if I can.
Mhm.
If for whatever reason I get pushback, I mean, I don't know if I will or not, but if in fact I get pushback, then worst case scenario, it ends up in CycloneDX. But even
Mhm.
so, we can externalize it as an external schema, kind of like what we do for SPDX license IDs.
Yeah, sounds good.
So, all right.
Yeah.
Okay.
Cool.
All right. I think this was a useful call.
Mm-hmm. I think so too.
Okay. All right.
Steve, if I can be helpful anywhere, please do let me know as well.
Yeah. Well, you've done all the research on this, right? So you should know everything now, right?
No. Trust me, I've sent you the document. You'll realize. Lot to learn.
Okay.
Lot to learn.
Hey, I'm just a specification geek. There's, when we're developing parts of the schema that I do not have subject matter expertise in, I call in the people who do. And that's, we did that for AIML. We did that for formulation. We did that for cryptography. So there's a tremendous amount of subject matter expertise at the CycloneDX table, which I'm truly grateful for. So, but yeah, I will absolutely review the paper. I'm looking forward to it. And congratulations, by the way. That's no small feat. So, yay.
I I hope if you like it, then I'm gonna go ahead and submit it to IEEE.
Awesome. So then I'll have to pay for it.
Oh, I'll pay for it. I just want it to be published.
Fantastic. No, that's awesome.
Yeah.
All right.
All right.
Well, very good, everyone. Thank you. I think this was a productive call. So I think we have a really clear step forward. So I like this. So with that, I'll let everyone go. Have a great rest of your day, and I'll talk to you soon. All right.
Perfect.
Thank you very
Cheers.
much.
Thank you.
All right.
Cheers.
Bye-bye.
Bye-bye.
Bye bye.